Hello everyone, it's Teacher Sunny again. Today we're going to tackle a slightly more complex word problem, a fraction word problem. As usual, we'll solve the problem by drawing diagrams and then we'll need to use the method of quantity rate correspondence. So, as Teacher Sunny has often emphasized in previous videos, as long as kids master the two main problem-solving strategies, they can handle basically over 80% of application problems. You'll be able to solve them easily and confidently. Even for students as young as 4th graders, or indeed even 3rd graders, as long as they have successfully learned and understood these two fundamental problem-solving approaches, they will essentially be well equipped. It won't be a problem at all. Their problem-solving skills will definitely improve by leaps and bounds. Especially the method of quantity rate correspondence, as Teacher Sunny has clearly mentioned. This particular kind of problem-solving approach is truly and remarkably effective. In many cases, even a significant number of math competition teachers haven't thoroughly explained it in sufficient detail. Today, Teacher Sunny is going to use this specific problem to reveal a bit more, so that everyone can gain a much better and deeper understanding. This problem-solving method of matching quantities, it's related to solving equations. It can be used to solve equations. Can the method of quantity rate correspondence be effectively used to solve a system of two linear equations with two variables? Oh, there's no problem with a system of two linear equations. If there's a chance, Teacher Sunny will explain this in detail for everyone. But for today, let's just touch on it briefly and focus on understanding the problem first. A pile of cement, first 1/3 of it is used. Then another 32 tons are used. At this point, the amount used is 1/3 less than what remains. So, how many tons of cement were there in total? Alright, when we are analyzing the problem, as Teacher Sunny mentioned in the previous video, it's important to clarify the people, things, and events involved and how many of each are included. Then we need to carefully identify the crucial relationships between the various quantities involved and precisely how those quantities change over time. So, actually analyzing the problem thoroughly is just that. It involves translating a complex word problem into a more accessible and understandable form that we can grasp more easily and clearly. So, how exactly do we go about translating it? Let's proceed with this important translation process. Starting from the very beginning, we have a pile of cement and first 1/3 of it is used. What exactly does this initial statement tell us? This clearly tells us that this particular cement, right? Cement, isn't it? A pile of cement. So first, 1/3 is used. If this entire pile of cement can have 1/3 completely used up, it truly means that the total amount of this cement can be quite easily divided into 3 perfectly equal parts. I'll use 3 distinct triangles to visually represent this concept. Each individual triangle represents precisely the same amount, and it can be clearly divided like this. 3 equal parts. This is truly the real fundamental underlying logic of fractions. The denominator in this context represents the total number or a single complete unit, one that's entirely possible to be divided into how many equal parts. This is explained very clearly here, right? It seems pretty clear. Okay, so what about the numerator? How many individual parts out of the total denominator does it actually take up? Alright, so how many distinct parts are there out of the total 3? Yes, that's precisely what it truly means. Let's take a much closer and more detailed look. After utilizing some of the cement, there will inevitably be some remaining material. So, we absolutely need to clearly and completely account for these particular things. So, how exactly do we effectively express this complex concept? The cement you used, and the cement that's left? Yes, that's 4. Of course, here the number specifically refers to the quantity of 4, so there are 3 parts of cement in total. So first 1/3 is used, which means 1 part out of the 3 is used first. That means there are 2 parts left. That's correct. There are 2 parts left. All right, then some is actually used, approximately 32 tons. Then another 32 tons are used. In other words, another 32 tons are used. So the total amount of cement used increases, right? You used 1 triangle, then another 32 tons, so the overall amount used definitely increases, and the amount left subsequently decreases. It decreases by another 32 tons because it's already been utilized. So just drawing it out like this helps you understand. And then, at this point, the amount used is 1/3 less than what's left. Yes, at this point, the amount used is 1/3 less than what's left. So you need to be careful in understanding these fractions. It's less than what's left. 1/3 less, so then what about what's left? All right, in the second scenario, what's left is divided into 3 parts. Okay, what's remaining can broadly be divided into a total of 3 distinct parts. And then, how much did he use? It's less than what's left. So that's what it truly signifies. 1/3 less than what's remaining means that we are considering 1 out of the 3 equal parts of the total amount that was left. This implies that he actually utilized 2 of those 3 parts. Indeed, he used 2 distinct parts of the available quantity. You can understand it this way. He still used 2 parts, so then, as for the cement here, it actually means that in total, there are 5 parts in total. Okay, so if we carefully take just 1 single unit of cement, it's essentially divided into 5 distinct parts, which can be visualized as 5 individual circles. Does that make sense? Alright, then the crucial question is, how many tons is this large pile of cement? Let's take this. Once we accurately translate the problem, we can easily solve it. It then becomes much simpler. Why do I say that? Sigh. First, from the problem statement, we can clearly see the specific amount of cement used. At the very beginning, 1 full third was used, right? So we initially used 1 triangle, and after utilizing another 32 tons, it then becomes 2 circles, which equals 2 circles. All right, so here, let's make some very careful adjustments. Let's adjust the quantities and the fractions, and then we can match them up accordingly. This particular concept is used to solve the problem, okay? It's like this, a really big reduction. So to find the corresponding amount for 1 unit, we need to find what 1 unit is. And what is 1 unit? How many tons of cement are in this pile of cement? So I can actually just calculate it directly here. The amount is 32. Amount divided by the fraction. What about the fraction? Here, there are clearly 2 distinct circles, but for 1 complete unit, there are actually 5 individual circles, so it accounts for 2/5 of the entire unit. Then subtract 1 triangle. It's up here. Of the total amount of cement. 1/3, 3 triangles represent the total amount, so among the 3 triangles, it takes up 1 triangle, so 1/3. So we can accurately calculate it precisely 32. 1/15 just multiply. So that's equal to 480 tons. And this is calculated. So that's it. This is the corresponding amount. Of course, we can also calculate it this way, right? Or we can simply calculate it like this way. Why? Because, you see, the remaining one is essentially equivalent to this particular one. That is to say, it's equal to this one. All right, that's absolutely correct. So let's carefully adjust the amount a little bit. That is to say, 32 is indeed equal to 3 complete circles. It's not 30 yuan anymore. It's just 2 triangles minus exactly 3 circles in total. All right, now that we have the quantity and the fraction, we can calculate it. So its weight is 32. Quantity divided by the fraction. 2 triangles out of a total of 3 triangles, it accounts for 2 triangles. And then out of a total of 5 circles, it accounts for 3 circles. So it's indeed the same. We can all figure out that it's 480 tons. So this pile of cement is 480 tons. Have you learned it? If you have, please give Teacher Sunny a like and follow and share it with more friends to learn together.